Good morning, ladies and gentlemen. Let's make a start to what is described as the final conference of our COST Suburban Action, COST TU1206. Many familiar faces in the audience, but also some new faces as well. So you're all welcome. And also, I think we're linked up now to colleagues attending the water infrastructure workshop in another part of Bucharest, and you're very welcome also. The introductory slide here attempts to squeeze as many names onto the first slide as possible, and by and large I'm highlighting people who've taken the lead with some of our reports and workshops and activities, but there are many more people who have contributed to not only this talk but to the many activities which have been undertaken by our action in the last 4 years and have brought us to the conference here in Bucharest. But as you'll discover, this is not the end of a process. This is perhaps the end of the first phase of that process. We have ambitions to carry on well into the future in collaboration with a range of other organisations. So I'm taking us to the topic of this introductory session, and I'm chairing the session, so I have the pleasure of introducing myself. As the Management Chair of COST Action TU1206, I've had the pleasure of working with many colleagues over the last 4 years since we initiated the action under the Cooperation on Science and Technology programme, which is now part of the EU's Horizon 2020 programme. Changing relationships between geoscientists and decision makers, and that's the essential theme that's run through much of what we've done. The background, of course, is urbanisation of the world, the increasing pressure that urbanisation is causing decision makers, those who manage and deliver our cities. There are so many pressures converging. It's been described as a perfect storm in a recent report prepared for the UK government. And despite the fact that cities only cover 2% of the Earth's surface, they have currently on a global scale 56% of the population, and it's rising. Various estimates put it between 70 to 80% of world population by 2050. And whenever things go wrong, major flooding events, other major geohazards, they affect very large numbers of people, increasingly larger numbers of people. And with the pressures of extreme weather events and rise in sea level, particularly vulnerable are coastal cities. But cities also account for 80% of world consumption. They're hugely important economic drivers of national and global economies. And they're increasingly the focus for infrastructure development. And astonishingly, the World Economic Forum report from 2015 suggested that 60% of the area expected to be urban by 2030, which is not very far away, is yet to be substantially built. So this increasing urbanisation of European and global populations is really challenging the sustainability of our cities. And with increasing extreme weather events and so on, their resilience is also being put under pressure. Despite this, as geoscientists, the importance of the ground beneath our cities in ensuring their sustainability and resilience is often poorly recognised, but there are some notable exceptions. And it's a pleasure to see colleagues from Finland in amongst the audience who have been involved in some of the earliest work in master planning in Helsinki, but also sitting in the front row, Jacques Besner from Montreal, who has been one of the leading proponents of subsurface planning and use for many years. So it's a pleasure to welcome you here. And just to highlight the different drivers for those cities where initial steps have been taken in terms of using and planning the subsurface. In Montreal's case, it's privately developed to a large extent, and climate protection, the desire to use the centre of the city in the harsh winter, is a significant factor in pushing this forward. In Helsinki, it was a different reason. There was a desire to reserve underground, and much of the infrastructure has been put in accessible tunnels in the subsurface. So different drivers for different reasons. And elsewhere in the world, the pressure is also growing in terms of greater use of the subsurface, particularly in those parts of the world where space is at an absolute premium. City-states such as Hong Kong and Singapore and the vast metropolis of Tokyo are increasingly forcing themselves to make greater use of the subsurface because it makes economic sense, as well as conditioning the environment. For example, in Singapore, putting shopping malls underground to encourage people to use them in the humid climate there. So increasing the use made of the subsurface, and increasing consideration being given to put facilities within the subsurface. In Hong Kong, for example, it's rock caverns where it's relatively easy to drive into the sides of the mountains around the urban fringe, And it makes economic sense there to put a 23-hectare sewage treatment plant inside a mountain to free up space for development of a prime waterfront location for housing. So those are the cities that have taken significant steps towards making use of their subsurface, but ultimately we all will make more and more use of it. The urban subsurface is a crucial part of the physical environment of the cities. We live on it, but we also to some extent live in it. And construction of whatever form must deal with the structure and the properties and the hazards which the subsurface poses. Clearly we increasingly use the urban subsurface to relieve surface congestion. Now it may be for networks, for metro systems, tunnels, cables, sewage, drainage, whatever that may be. We have traditionally used the subsurface for that, but increasingly we're putting storage into the subsurface, warehousing, cellars, parking and so on. But increasingly we're looking at the opportunity for extracting energy from the subsurface, even at shallow depths, for example heat. And also we use it for shelter and protection, the passageways and the relief from harsh climates, hot and cold climates regardless. The subsurface also retains a very distinct and remarkable physical record of the history of those cities. Now it may be valuable cultural heritage, archaeological assets preserved at or near the surface which need protection, but equally our cities, particularly former industrial cities, reflect the previous uses in the form of polluted soils and abandoned mine workings, for example. So there's an awful lot in the subsurface, perhaps which we would rather was not there, but we have to deal with it. But substantially, the subsurface in most city planners and decision makers' minds is largely out of sight and out of mind. This is largely because it's not really a daily concern for those planners and managers, unless there is a problem. That's the background of our suburban action, and this is really what we would like to change in terms of a culture. We've been moving in that direction with many colleagues across Europe in particular. Our aim is to provide those who manage cities with the knowledge and tools we think they need, and we need their input to that, of course, and they've had that input during this action, to maximise the economic, social and environmental benefits of subsurface resources, whether that be something physical that can be extracted from the subsurface or the valuable asset of space. To enable them also to recognise and to manage responsibly the conflicting demands that are increasingly placed on the subsurface. Very often things are approved without realisation of potential conflict which might arise on a much wider scale than the project scale. It's our duty to broaden that scale of consideration. And really to safeguard the subsurface ecosystem services, and many of the fundamental ecosystem services which we rely on in our cities for their sustainability are linked, at least in part, to the subsurface. And we need to ensure their sustainability also. Ultimately, our aim was to make a difference to our cities. The key aspiration, of course, was to bring together those experts who develop urban subsurface knowledge and those who can benefit most from it, the urban decision makers, practitioners in the private sector, consultants and contractors, and the wider research community, which is a hugely important asset in everything that we do. It's to bridge gaps between these disparate communities. And that is no easy task because it involves communication which necessitates common language to be developed, common language and understanding. So our role in this large European network spanning 31 countries has been to coordinate the existing research which takes part in many parts of Europe. Many of us are aware of some of it, but nobody is aware of all of it. And there are fascinating and excellent pockets of research taking place all over Europe, and we can all benefit from coming together, and we've been doing so. But particularly the European Geological Surveys is one of our targets. These are large organisations which traditionally have not greatly involved themselves in urban issues, and we think they have a major role to play in doing so. To share, particularly in Europe, but also beyond, because the COST network is keen on globalising some of our abilities and capabilities, the techniques, methodologies and subsurface geoscience knowledge which is available within Europe. And using that to inform and empower our policy and decision makers so that they can appreciate the opportunities, the challenges which the subsurface presents. And crucially, to broaden the relevance and impact of this knowledge, there's the need to make subsurface knowledge interoperable and interconnected with the extensive range of disciplines of knowledge which exist and are used above ground. It is not for them to change their practice, it is for us to change ours, to make the knowledge more accessible. Within our action structure, we've very much put the cities interests and needs at the heart of our action, and those who contribute to its understanding of the subsurface around the peripheries. It is for the cities to determine our pathways, our direction of travel. They are key partners, the city partners. And in that regard, we have touched on many of the cities across Europe, some to greater, some to lesser extent. But regardless, these is an indication of the interactions that we've had with people who work in and for cities across Europe, so a reasonably good spread. The key opportunities to identify and the challenges to address in terms of the subsurface, which many of the experts in this room have knowledge of, linked to the already sophisticated systems of management of above ground as well. In terms of conflicting use of the urban subsurface, much of it relates to the fact that we have different uses of the subsurface for different depths. Different range of depths for use depending on what we want to put into it or what we want to take out of the subsurface, whether it be infrastructure that we're putting in place or taking energy out of the subsurface. There are different uses that we can make. Potentially, some of those uses can conflict, of course. We know examples, for example, such as the use of sustainable drainage, where infiltration techniques are being used in one part of a city and have caused groundwater flooding kilometres away in some cases. So we need to take the wide view as to what we are approving and undertaking. Water is always a crucial issue in terms of the subsurface, and much of the activity which has taken place within this action has been related at least in some way to it. But we always have to consider the possibilities of what we do, for example, to groundwater level. When we abstract water, we may be impinging or inflicting or conflicting with an existing use. Some of these ground source heat pump may become inoperable if we increase abstraction in a different part of the city. Equally, decreasing abstraction, and that's a problem in many parts of Europe with reduced need for water related to industrial practice, raises the groundwater level to levels it was not assumed to be norm at for many other existing uses. It's an issue here which is particularly being addressed in Bucharest, for example. And sustainable drainage, well, opportunities for using the infiltration capacity of the unsaturated zone of the subsurface are going to be reduced if groundwater level is allowed to rise and not being managed in a constructive way. But really the opportunities for layered use of the subsurface, vertical layered use, lateral use of the subsurface, present themselves, and this has become increasingly apparent to many of us during this action. And the need for not just one use being allocated to a particular area, but potentially multiple uses, which can coexist quite happily. This really encourages us to move in the direction not so much of spatial planning, but of volumetric planning, where we allocate use to volumes from the subsurface. That requires a considerable level of knowledge and understanding of the subsurface to do so. The journey that many of us as experts in relation to the subsurface have been taking is this staircase from data to impact. Traditionally, organisations focusing on the subsurface, geological surveys particularly such as my own, have traditionally emphasised the importance of mapping and data capture. And to deliver raw geological maps to city decision makers is an exercise of relatively limited value and impact. How do we expect that information to be used by people who do not have a geoscience background? Crucially, we need to close the gap between the geoscientists and the decision makers. And the further we move from left to right across this diagram and up this staircase, the closer that gap becomes, we believe. Many geological survey organisations and researchers have been moving in the direction of 3D models, of increasing sophistication, deterministic models, and increasingly stochastic models. That is an improvement, but that in its own right is not the sole answer. We then need to make these models predictive. We need to add a 4D, a time component to these models to make them more valuable tools to the decision makers in terms of what is likely to happen, for example, to the groundwater if something is changed within the system. But even that's not quite enough, because we're still required to close the gap by bringing this knowledge into the format and operability with the tools which are already used by city decision makers. When we can start to do that, then we could really start to have impact. It requires monitoring time series monitoring and censoring of the subsurface, recognition of the need to avoid conflict in the use of the subsurface. And for that, this action has been drawing together a toolkit of knowledge and capability and good practice to bridge the gap. We believe with that in hand and with improvements being added to that, we can then start to have significant economic, environmental and social impact of our knowledge and understanding. Crucially, it comes down to improving the translation of data to usable forms. Our action has been built around a series of working groups, initially to compile the state of the art as to what is known and what the subsurface is used for in a range of cities across Europe. Then the second package working group has been evaluating and assessing good practice and best efforts and drawing those to the fore. Then the third task, to develop that toolbox of capabilities, guidance, methodologies and techniques and making them available. And finally, this whole issue of communication and dissemination of the toolbox and its findings. The Working Group 1 reports, a whole series of them, you'll see them upstairs, have been looking at the state of the art in various selected cities within our action. Focusing on the interactions between the urban and subsurface domains, drawing together planners particularly and geoscientists, writing different sections of those reports and working together. Focusing, yes, on the acquisition of subsurface data and their interpretation in useful subsurface models, and also considering the transferability of the data and models to planning documents, to the right phases within the planning decision-making process, which is hugely crucial. An excellent series of reports, but what it also brings back to us in terms of the typology of the cities is that every city is unique. There are some common factors, but at the end of the day there will never be one size fits all in terms of what we can recommend, and we should never attempt to try to do so. We must make knowledge available in its variety of forms and let people decide for themselves what is and isn't useful to them in terms of the city setting, planning issues, the underground, economic aspects, drivers like the quality of life, governance issues, ownership of the subsurface. It varies across Europe. The individual reports have been synthesized in a single document, out of sight, out of mind. And all of these documents can be downloaded from our website. Moving on to identification of good practice, we've brought together groups of expertise, focusing on, for example, subsurface urban planning issues, data management issues, 3D modelling, groundwater geothermal monitoring and modelling, geotechnical issues, geochemistry of the subsurface, and its cultural heritage. And these reports have also been delivered. So pretty much what we've said we would do in the 4 years of the action, we've done. And it's thanks to people sitting in this room and some who can't be here today. Let's just look at one or two aspects of what comes out of these reports in terms of good practice. Data is always crucial. Accessibility to data, usability of data is fundamental. If it isn't right, then nothing else can be built. It's the foundations of everything. And in this regard, obviously, with the ability to acquire digital data and transfer digital data more readily than has ever been possible before, we must make good use of that. And there are two fundamental ways that this is being done. The Netherlands has taken the lead in terms of using the legal process to do this, to require, for example, in relation to government bodies, that they must provide data in standardised forms, deliver it to the Geological Survey of the Netherlands, who then have the responsibility of integrating this knowledge into effective, useful and relevant models of the subsurface of the Netherlands. It's been operational for a relatively short time, and it's a major challenge to deal with all of this, but it's an excellent initiative, and it's one that we all must be aware of. In other parts of Europe, such as my own, the legal process is not always the preferred route, and there's a tendency to hope that the community will do this on their own. In Glasgow, for example, a knowledge exchange network has brought together public sector, private sector and research sectors to share their knowledge, and it's happened to a remarkable extent, the willingness to share data and knowledge, and it's an encouragement. And it's been supported by a standardised industry format data transfer template which has been used, which actually much of industry used anyway, but simply weren't handing it on to other potential users. Now the mechanism is in place to do this, and on the back of that, so much becomes possible in terms of a fundamental virtuous circle between those who produce subsurface information, typically contractors, consultants, and paid for by developers, those who can store it and make it available, typically geological survey organisations, but in some countries it's the universities, such as in Basel, for example, who do this role. Draw the knowledge together in useful and usable forms, typically models, 3D and 4D models, even 5D if you consider uncertainty as one of the dimensions, and to deliver it back to a range of end users, whether they be decision makers in local authorities, regulatory authorities who have particular functions to perform, or back to the private sector to help them plan their projects and design their projects. The virtuous circle keeps going round. More data is added to it, it fuels the process. And the ultimate goal then is to embed this subsurface data, knowledge and understanding in the very fabric of urban decision making. National exemplar modelling projects have been a key element of what we're attempting to do. Picture of Ingolf Eriksson here with the Oslo project, which has essentially paralleled the evolution of this action. And inspiring too. But the range of modelling projects in each of the national partners, we've encouraged the development of a lighthouse in one city for other followers to emulate, to cascade the approach. And it's starting to happen, looking at a whole range of subsurface conditions there, and to inform a whole range of different decision makers. Again, the no one size fits all. Just a few slides here from the Oslo model, and you'll see better examples later today in terms of capture of the data, geotechnical data, building it into geological models in cross sections. The infrastructure, absolutely crucial. Very often this is missed out in many of the models that have been produced previously, but all the pipelines are there in place in that modelling. The basements have been put in place, and even the surface structure as well, the buildings. Taking these static models and making them dynamic involves putting some form of other data, a second modelling process. Typically it's hydrogeological, hydraulic connectivity or whatever it may be, to parameterize the models and to use them for a predictive process. But it could be engineering properties, geochemistry properties, thermal properties, or whatever. In this regard, there are several national exemplars which have looked at different aspects and are driven by different processes. In Bergen, it's preservation of the threatened archaeological deposits and buried archaeology. A sixth model has been produced, and it's a hydrogeological model which is fundamentally in deciding what can and can't be done. In Vienna, some very sophisticated modelling has been carried out and is already embedded within the decision-making process of several elements of the city of Vienna. An excellent example of delivery in terms of the hydraulic properties, engineering parameters, and groundwater system, and heat as well. For Odense and so on. Another model which has followed our process through the cost action. A hydrostatic model is being developed, essentially driven to understand groundwater infiltration and extraction, its effects on formal wetlands. In Glasgow, one of the key drivers has been the previous mining history. So particular modelling there has involved very detailed modelling of the bedrock. Models have to have a purpose. There is no one size fits all. These are valuable predictive tools, but they're not substitutes for ground investigation. Increasingly, their relevance to city-scale planning is providing context for site-specific issues. And crucially, we have to consider the role of visualization in all of this, to use the words of our colleague Ignace, to inspire and seduce people who are less familiar with the subsurface. Here an example from Glasgow, where we can go underground and see some of those mine workings in their true context. This is encouraging people to consider the potential to make use of the enormous heat potential of the abandoned mine workings which underlie over half of the city. Other things which are coming out, effective workflows. Very flexible workflows in terms of groundwater models for urban areas, which our specialist group have brought together. I won't take you through the details, but you'll hear more of this over the coming days. And the exciting possibility of looking on a city scale for city information modelling to put the subsurface into its true context in decision making and thinking. There's already great move within the construction industry to move towards building information modelling. Very often this pays scant regard to the subsurface, and what we want to do is to increase the impact of the subsurface information in that, to make it a fundamental part of the life cycle of building activity, but not just on a project scale, on a city scale, to take us around what is yet another virtuous circle, from planning to design to construction to maintenance to demolition. It all has its impact. And in this, I particularly highlight the growing influence that the Netherlands 3D stochastic modelling is having. This really is increasingly the way that modelling is moving, taking layer-based approaches and adding stochastic mathematical constructs. But it requires a lot of data. And then delivering it through the toolbox. Nearly finished, Guri. You will hear over the next couple of days and get a chance to use the toolbox, to experiment with it in your own ways. A web-based approach to make all of this information we've been drawing together available to subsurface specialists, to urban planners, to decision makers, different entry points to the toolbox for people with different backgrounds and needs. A set of examples of products and good practices to close that gap. I won't attempt to explain the bicycle model that Ignace van Kampenhout sees the entire world in. Being Dutch people always see bicycles as being the way to explain everything. And it's all to do with linking supply and demand. And the decision makers, of course, sitting on the saddle, directing the process as they expect to do. So, in summary, last slide. Where are we now? Well, we are at the end of phase 1. This is not the end of the process. We've made good progress in realising the benefits of transforming public-private partnerships and communications, bringing the wider community of subsurface experts and data users together. We've made good progress in recognising the importance of data, its acquisition, its availability, and particularly its reuse. There is so much data in urban areas that is never used more than once. In fact, there's an awful lot of data in urban areas that's never used at all. It's part of a tick box exercise. It's acquired, put in a folder, and forgotten about. That can improve enormously. It requires good data standards to do so, and good mechanisms to store the data and make it available, but they are becoming available. Discovering how to design workflows, the toolboxes of knowledge and guidance, to improve the predictability and, as a result, the risk management of the subsurface. These are things that have enormous economic value. They help us to deliver things better, on time, within budget. And particularly to address this chronic impasse of unforeseen ground conditions which bedevils the construction industry the world wide over. It is the biggest single cause of construction delay and overspend. Is it unforeseen? Is it unforeseeable? Or simply it is not seen? And finally, to encourage this more holistic approach, appropriate to scales of development and timescales of development. Fundamentally, whenever any sort of data acquisition and modelling is undertaken, the important thing is to ask, what is the question? For that, you need to communicate with people who ultimately need that knowledge. Thanks very much.